Properties of magnetic field. My dear students, first we will see what is meant by a magnet. Some metals or elements in the nature or their minute particles emit some energy. The atoms of the metals like nickel, iron, cobalt exert an attractive or repulsive force under certain conditions. This force can be represented by the imaginary curved lines emerging from the metal. These curved lines are directed. Some stones available in the nature also show such properties. Now you may ask, why this property is not shown by each and every piece of metal? For this, we will see an example. Many children have gathered in the school playground. Consider every child as a source of energy. Some children are playing in the groups, while some are on their own. The energy is scattered among all the children. Can we get any job done from those children? No. Now imagine that there is an empty but heavy water tank in the playground. This tank is to be moved to some other place. What should be done? The physical education teacher arrives. He whistles to call the children. The children give up their play and gather around the teacher. The teacher disciplines them and arranges them in a row. He tells them about moving the tank. The children are instructed to apply force together in one direction and a rope is tied to the tank. Then all the children pull the tank at the same time in the same direction. This results in displacement of the tank. The tank is moved to the desired place. Students, exactly same thing happens in the metals that exert the magnetic force. Every particle of such metals has the magnetic properties. However, these magnets are scattered. They are not aligned. When this metal is subjected to an external magnetic force, these tiny magnetic particles exhibit together their total magnetic force. Each particle is a magnet. This magnet has two poles. One is the north pole and other is the south pole. Magnetic force is represented by the magnetic lines of force. Magnetic lines of force always run from the north pole to the south pole. This has been explained by the scientist Michael Faraday. Now we will see how these magnetic particles are aligned. Place a steel bar AB on a table. Take a bar magnet. Place its N pole, that means the north pole, on the end A of the steel bar and drag it towards the B end. Lift the bar magnet and drag its N pole from the end A to the end B of the steel bar again. Repeat this 15 to 20 times. Now take the steel bar near some iron filings and observe what happens. The iron filings are sticking to the bar. Hang the bar freely by a thread and observe. The bar remains steady in the north-south direction. We can notice that the steel bar shows magnetism. This method of magnetization is called the single touch method. The magnetism created by this method is of low strength and lasts for a short time. बंधू भगिनींनो, मुलांचे उज्ज्वल भविष्य म्हणजे आपल्या कुटुंबाचे तसेच राष्ट्राचे देखील उज्ज्वल भविष्य आहे. त्यामुळे आपणास विनंती आहे की बुद्धिराज e-learning.com या वेबसाईटला भेट द्या. त्यावरील फ्री डेमो व्हिडिओज, प्रश्नोत्तरे पाहून आपली खात्री करून घ्या आणि आवडल्यास नक्की सबस्क्राइब करा. हा संपूर्ण अभ्यासक्रम आम्ही अगदी माफक किमतीत उपलब्ध करून दिलेला आहे. बुद्धिराज ई-लर्निंग ही वेबसाईट आपल्या मुलांच्या अभ्यासात नक्कीच सकारात्मक बदल घडवून आणेल याची आम्हाला खात्री आहे. अधिक माहितीसाठी या ठिकाणी दिलेल्या फोन नंबरवर कॉल करा. धन्यवाद.